are discussions that Haishi will start today that you're interested in learning more about or wanted to follow up on, you can feel free to look on the YouTube to rewatch this session. Cool. In addition to that, I also wanted to bring up some of the um, some of the mechanisms that we've created for community involvement for the open source community. So to stay appraised of all updates, I would encourage you all to join the Symphony OSS Google group, which many of you are a part of, and get regular updates and news about Symphony. Now, our goal here isn't to barrage you with multiple emails per week. Our cadence on that is about one to two emails every 2 weeks. So you can see about 5 emails per month. But where you will, if you want to get really active in the community, I would highly encourage you to join our Discord. This is a place for the open source community just to connect and talk with, whether that be me, Haishi, Charlie, and the rest of the team as well. But more importantly, it's a chance for you guys to connect with the wider community and help each other grow. That's what's beautiful about an open source project, right? Last week, we kicked off our weekly office hours. Haishi started hosting that on the Discord channel, so join him every Wednesday from 8 to 9 a.m. Pacific Standard Time. That is usually this time, so we will be having every month, the third week, we usually have our Symphony community call, which is happening right now, in lieu of the office hours that week. All right. Now, what are we doing today? So here's the agenda for today. Because the holidays happen, in terms of our release, there isn't much to talk about there, but there are some really great contributions. If you're interested in viewing the release notes, you can feel free to click this link here. But since we have a lot of new attendees today, we thought it'd be really great for Haishi to just take a full step back and just give a Symphony tutorial on what that entails for the user as you set it up, and I'll let him take it from there. He'll also be going over a hypothetical on what Symphony and AI and what those two together look like. So I'm excited to learn a little bit more about that, and hopefully we can spark some interesting discussion within the group as well. That'll be interesting to hear. And after that is an open Q&A. So if you do have any questions for any topics that were raised today or not raised at all, please feel free to bring it up during that session, and we can have a further discussion about that. But without further ado, I will hand it off to Haishi.
Okay, thank you, Harry. Let me bring up my screen. Okay, I hope I'm sharing my screen.
Yes, we can see it.
Okay, great. So first of all, thank you for joining this community call. I think I will start with the new release, the 48.33. This is our latest release. As you can see, there's a whole bunch of stuff went into this. So in the past few releases, we mostly focused on quality improvement work. For instance, we did some improvements in the campaign loggings, and also to improve the concurrency of the system. And we also started to work on revamping the document site. We've heard feedbacks that our documents are kind of lagging behind. And now we are trying to put the document into our regular CI/CD pipelines, so that we'll keep building the new doc site as we build our releases. So you can see a few changes related to that. And I think in the next community meeting, hopefully we can showcase how the new document site looks like, how to actually to make contributions to the documents as well. So I think as Karen mentioned, right, for this iteration, we will just present like a Symphony tutorial, just kind of like a reset the stage, right? Let's say if you are new to the Symphony repository, and if you want to get something going, and what would be the steps. So the Symphony project is currently hosted under the Eclipse Symphony org. There are several repositories. Like I said, we externalize the docs and our landing page to separate repository, so that if you just want to make contributions to the docs, you can actually work on the docs repository. But we are still in the process of migrating this, right? We don't have much at the moment. But I think it's hosted on the docs site now. Over time, we will start to migrate stuff into this proper doc site, because originally we just have the markdown files. It's not really very friendly to navigate through. Hopefully, over time, we will make it better in the proper doc site. And as I said, this is built with the release pipeline, so hopefully we will try to keep it up to date. But the main repo is still Symphony. So basically, this contains all the Symphony source code and samples. And we currently we have the docs here in the main repository. But the idea is that we'll gradually move this into the corresponding sites. And if you want to work with the Symphony repository, so basically after you clone the repository, right? Now I think I'm on the main branch. Symphony is built on top of Go, so the main building tool will be just the Go toolchain. And we use a Mage, which is a Go-based tool, to build a lot of components. If you go to the tests folder, and there's a local environment. So this folder is for you to run the inner loop, right? If you want to do a Symphony contribution, and if you want to build up Symphony to test it out, you can use this folder. There's a whole bunch of Mage recipes. For instance, you can build the APIs, or you can build the Kubernetes bindings, or you can build everything. This will build up all the Docker containers, as well as the Helm chart. Actually, to build everything, you can just do Mage build all. This will build all the source code, and it will also package the Docker containers. And this will become available. I mean, I don't think this script actually pushed to the Docker registry. So even if you don't have a Docker registry, it's fine, because it's just cached locally. And once this is done, you can use build a Mage test app. So what does this do is to create a brand new Minikube cluster. Then it will install the Symphony Helm chart that we just built onto this Minikube cluster. So you have like a brand new environment, because everything is cleaned up. So you can just try out your versions in this way. Of course, this is like building everything, right? We're packaging the containers, packaging the Helm chart, and deploying the whole Helm chart. if you just want to build, let's say the API layer, right? Go project, go source, GitHub, Symphony. If you just want to build the API binary itself, you can just go to the API folder. This is our REST API, right? This is the primary way you can test Symphony. You can just do a go build, let's say Symphony API, just give it a name. Basically, you can just build the API folder directly. Then you can launch the API as a REST endpoint. Then you can use regular like HTML debugging tools to access this. So there are different ways, right? You can build the API, just try out the binary by itself, or you can just use the Mage tool to build everything. So this will be like a very close simulation of what is actually deployed if you deploy Symfony for real. So it depends on where you are. You may want to try to different routes. And also, Symfony actually, we built up a lot of test cases. A few months back, there was a big effort to increase the code coverage. I think we went from like 20% to like 60, 70%. And we keep in terms of code coverage, and we keep improving on that. So this API build is done. So if you want to launch this, you can do Symfony API, then you give it a configuration file. Under the root folder, we have a bunch of configuration files. Sorry, I think it's actually under this folder. Symfony API, no Kubernetes JSON. Then you can launch a debug. So basically, this just launched the REST server in the console window, and you got to see all the logs, right? So if you want to test something and you want to see the logs on the window, it's an easy way to do this. And on the upper screen, you can see this is actually installing the Symfony Helm chart. And if I do the kubectl service, you can see now we've installed all the Symfony related services. And you can see all the Symfony objects. I think in this version, I mean, if you came from an older version of Symfony, something worth noticing is these containers object. So initially, Symfony doesn't support versioning. So basically, it's an immutable infrastructure paradigm. Let's say if you want to define a new version of the solution, basically you have to create a new solution object, right? That becomes your new version. And that's still what you do, right? Let's say if you have a version 1 or version 2, those will be corresponding to different solution objects. But what on top of that, we introduced the solution containers. So basically you can group multiple solutions into one container. So what this gives us is this ordered list of solutions so that we can establish the concept of the next version and the previous version. This sets the stage for us to do rolling forward and rolling backwards as needed. Because with the solution containers, we now actually have trees of all the solution versions. So this will allow us to do this rolling forward and the rolling back scenarios. And similarly, we introduced versioning to like a campaign. That's the workflow, right? And also, I think, yes, solutions and the campaigns and the catalog. That's the information graph, right? So that's the versioning support of these three object types. And so there's also this catalog evaluation expressions. I mean, this object is kind of strange. Actually, this was introduced to specifically enable evaluation of catalog objects. Basically, if you're not aware of this, let me try to find a good example of this. I think XP. I mean, I think this is let me see. Yeah. So basically, our catalog object, one of the main use cases of catalog object is to describe a hierarchy of configurations. Right. Actually, let me launch a notepad. Let's say in application, let's say in your solution definition, you can define a property. Let's say this full property is actually from a config. You can say this config is from bar, right? So basically, you can say the property of this full property is from a configuration object. Actually, you need to give a key, right? So this is a configuration object. This is the key inside the configuration object. And this config will be resolved to a catalog object. So basically, we'll look for the catalog object. We'll look for this bar object. And then we will read the key property, right? For instance, my catalog, let's say this is called bar. Inside there will be a key property. This is the actual value, right? So at the end, this full property of solution will be resolved to this value. But in the artifact, right, this is how you write. This is what we call the Symphony expression, that you can use this kind of expressions to refer to another object. But the feedback we heard from some of our customers is that they want to be able to evaluate this expression as a separate exercise, right? Although these expressions are evaluated during our deployment, they want to be able to independently evaluate these expressions just to see what the final result will be. So that object is actually designed for that. So basically, if you have an expression, you can evaluate this expression using this object. And if you're curious about this expression syntax, it's under the API folder. You choose. We have this parser, right? So basically, this is our own expression language that allow you to do like a dynamic expressions. So for Symphony, we support a concept called contextualization, which means let's say when you design your application, you may have some settings that is not known beforehand, but can be only dynamically resolved at the deployment time. And a very example is like machine IP address, right? When you write your application, you don't care about a machine IP address, but when your application is deployed, there might be a configuration you need to supply to the application to inform the IP address of the actual target. And this is what the expression comes to play. Basically, instead of hard coding that in your artifact, you can use expression to say this will be a dynamic property that will be resolved during the deployment time. And from the test cases, you can see like a samples of different expressions we support. Actually, we support quite a few expressions. For instance, you can read configurations, and you can actually define an override chain about configurations, and you can also access like a secrets, and you can refer to like the object in the current context. For instance, when you do an instance deployment, you can actually read the instance properties as well. And there's a whole bunch of that. And I think we have a doc in the doc folder as well. So definitely from some of our large customers, this kind of dynamic expression can really help them to reduce the number of artifacts they need to maintain. Basically, they can use these to refer to the actual deployment context, and those values will be resolved on the fly. So it's actually quite a powerful tool to use if you have like those kind of dynamic configurations you want to inject into the application. But for now, going back to this deployment, right? I have the Kubernetes Symphony deployed to Kubernetes. Then because this is in the bottom, this is a REST API, right? You just do like a CRUD operations against the REST endpoint. And to the top, everything is accessible through the Kubernetes API, so that you can just use a Kubernetes native tool like kubectl to interact. So for now, I'm going to just do like a hello world, which you can find under the our docs folder, Kubernetes hello world. So this hello world example shows the most basic usage of the Symphony. So basically, you create the solution, which is your software. So in this case, I'm creating a solution with one container based on the Prometheus container. So that's my software. And like I mentioned, right, this is a newly introduced container object. Basically, you can group multiple solutions into the container. In this case, the solution will have a reference. It will say the root resource is this server, and the version is actually version 1, right? And after you have your software, I mean, in parallel, you can define your hardware, or more accurately, this will be the hosting environment for your software. In this case, I'm just declaring the Kubernetes cluster itself as the target. Actually, this is in the same cluster, so it's just easily say this is the same cluster. So, and then you can start to define deployment. The deployment is a mapping between your software. So I'm taking this software. By the way, after we enabled versioning, now you can have this nicer syntax, right? Basically, you can just say this container name, then you give it the version number. So this is pretty much like how you specify your Docker image or Helm chart versions. So it gave you a similar syntax so that you can have this multi-versioning experience. But like I mentioned, right, under the hood, we still use multiple solution objects. So we remain true to the immutable infrastructure paradigm. This container object, however, gave you this like a multi-version experience. This can be used in your tooling or in some kind of portal experience to have this multi-versioning. And once you have this artifact, you can just deploy this. But before I deploy this, I'm going to make a change. Because here you can see the service type is set to load balancer. This wouldn't work on Minikube because Minikube doesn't assign you a public IP address. So what happens is that Symphony will keep checking if this service is deployed. Actually, this is a new behavior since I think version 32. Before, after Symphony triggered an underlying toolchain, it will just considered a success, right? If the toolchain doesn't report any errors, we'll just say, hey, now we will successfully invoked the toolchain. But now we are adding in more checks. Not only we want to invoke the toolchain, but we will also want to make sure the toolchain is doing what it's supposed to do. So what happens now is that Symphony will keep waiting for this service to be fully provisioned. But because of the Minikube limitations, this will never finish, right? So to make this to work with the new version, basically you need to change this to like cluster IP or node port, so that Symphony will when the Symphony checks for this service, it will see this is actually deployed, right? Otherwise, Symphony will be waiting for the public IP address to be assigned. So once I have that, if I do go to docs samples, okay, yes. Hello world. Actually, before I do that, I will just get the namespace. You can see I don't have like the sample namespace in there. I will just do kubectl apply solution container. Then I will apply the solution. Then I will apply the target. And now I'm ready for the deployment. And if I get the instance, so this is reconciling, and this is another change we did in the latest versions. Basically, now we are refreshing the status more frequently, so you can actually see what's actually going on, right? So now this instance has been deployed, and if I get the namespace, you can see this namespace is created, and if you the CTL gets all from this namespace sample AAS scope. So basically, you can see the part, the services, and because this is a class IP now, right? So it's okay if it's an external IP is not specified, and we have the deployment and such, right? So this is actually just a quick demo of like how Symphony works. Of course, that doesn't show the actual value of Symphony, right? Because Symphony is designed to manage the heterogeneous environment. Let's say if you deploy across Kubernetes and Windows, and if you deploy onto multiple virtual machines, etc. That's where we really showcase the capability of Symphony. But the good thing is that regardless how complex your solution will be, the workflow is exactly the same, right? What I showed you still applies to a more complex solution. So the workflow is still you create the software, you create the hardware, then you create the deployment, right? This workflow doesn't change. So that's just a quick tutorial of how you can deploy Symphony and try something yourself. And I think I'm going to move to the next topic, which is Symphony with AI, right? Which I think that's like a more interesting topic. So basically, we are trying to do a few things with AI. The first thing is that in our sample portal, which is called Opera. Actually, let me try to bring it up. So if you go to the Opera, that's the sample portal. Let me see. Sorry. Let me think if I can run this here or have to deploy it. Give me a second. If I run this, maybe it will not work. But anyway, let me just try to run this in the dev set. Actually, the Opera portal, it uses our REST API, which means if you actually directly access this Symphony service, but as you can see, because we deployed on the Minikube, this is set to cluster IP, right? It doesn't have a public IP address. So I need to do a port forward. As we see, Symphony service 8080. Okay. Now I should be able to see the portal. But of course, because I'm running under the development mode, everything is compiled on the fly, so it will be really slow. But if you create like a build version, it will be much faster. Let me see if this is the right version. So what we're doing is that on the portal, we're adding, okay, this is the wrong version. Apologies for that. So basically that branch hasn't been merged. But the idea is that we will have this Copilot page where you can just describe your scenario. Then we will generate the Symphony artifact for you. Then you can just review it and deploy it directly. So because Symphony it's a toolchain orchestration engine, right? We try to orchestrate multiple toolchains, and we're actually not hiding any toolchain functionalities. So your solution definition could be complex, right? Depends on the underlying toolchain. So the idea of this Copilot thing is that for you just to describe what you need, and we will create the artifact. So this will at least give you like a guidance or some starting point that you can create all the necessary Symphony artifact. Then you can iterate on that, and then you can deploy that. So that's the first thing we're trying to do with Symphony. The other is that to try to use Symphony to manage the AI payload. This is not like the large language model payload, but more like the traditional models like computer visions, anomaly detection, those kind of models that you want to deploy to your edge environment. I think some of you know that there's a separate project called CAN, and that is based on an older version of Symphony. And now we are discussing if we should merge that CAN project into Symphony, probably as a sample, so that you can have like a similar portal experience to manage your edge AI solutions. And the third aspect is actually that's the most exciting one, is that as you know, right, Symphony has this concept of providers. We have two main provider types. One is the target provider that participate in our state seeking process, and we have the campaign provider that participate in our workflow. And we definitely we look forward to community contributions to contribute new providers. And at the same time, we are also experimenting how we can auto-generate those providers, especially to a tool chain that have reasonable documentations or even API definitions. So the idea is that we will use code generation. Let me bring up the slides. So the idea is that we'll use the code generation to auto-generate those providers so that we can like bring in supporting of new systems more easily. So in that case, basically, what you need to supply is a scenario description. For instance, I mean, this is like a fictional, right? Let's say if you want to do like a Terraform deployments, basically you just describe, I want to use Terraform artifact to deploy Terraform-based applications. So that's the description you supply to Symphony. And then we will do some prompt augmentation in the background. Then we will feed that into the code generation logic. Then we will actually generate the provider into the code library. But that provider will be locked, right? It will not be available to you yet because we want to have some assurance that the provider is functioning correctly before we actually allow that provider to be used. And this is where we have this automated test generation. So basically, once the provider logic is generated, we will use a symbolic execution basically to detect all the possible execution path of that provider. Then we will generate the test cases, and then we will use test execution engine to run those test cases. And then this provider will be either auto unlocked to be used, or we can still keep the human in the loop validation, right? So we can still require explicit user approval before the providers can be approved. And then once this provider has been validated, has been tested, we can actually export the provider into like a verified library. And then the providers in this verified library can be fed back to the code generation as additional grounding. So as we do this more and more, hopefully we will start to generating like higher and higher quality of providers because we have more and more data basically to fine tune or provide additional grounding to the code generation. And for that one, I want to show you a quick demo of a prototype we are building. So in this prototype, we are actually using JavaScript instead of Go, just to try out the ideas quickly, because there's a lot of tools that is available for us to run the JavaScript-based test. So in this quick example, I'm going to basically test this very simple function. So this test function basically says if the parameter is larger than 10, it will return greater. Otherwise it will return smaller. So as you can see, there's basically two execution paths, right? There's a greater path and smaller path. And we want to generate the test cases to test all the possible cases. So if you look at the Python script, so basically we have a function to write the code file. Basically, expectation is that the user will supply this function to us. but we need to rewrite this code file to include some exports so that we can reference that into in our test script, right? And we'll do the analysis, code analysis. This is where we use the symbolic execution, trying to extract all the possible execution path. And then we will use OpenAI in this case. We will generate the test cases, right? You can see the prompt we are trying to construct. And then once the test cases are generated, we will create a test file. So in this prototype, we chose to use Jest, which is the unit test framework for JavaScript. So in this case, we are just generating a Jest test file, which I'm going to show you in a moment. Then basically we'll just invoke Jest to run the test. Then we will collect the test result and calculate that like the code coverage and such, right? So I'm going to my PowerShell somewhere. Okay, I'm just going to run this. I think it's called applev. Right. So what this does is that basically it's reading that code file, is writing the code with export. And then you can see this is what we extracted using the symbolic execution. So basically we discovered there are two branches. The condition is larger than 0 is true, not larger than 0 is false. And then these are the test cases generated by OpenAI. So basically we take the code and we also supply the extracted paths to OpenAI to say, we are going to test this function, and here are the possible execution paths we detect to help you to generate the test cases. As you can see in this case, I think this is a fair coverage, right? So basically, the OpenAI generated a larger than case, 11 case, this smaller than case, as well as a boundary case, right? Because the condition is 10, right? It's also generated a boundary case. And once you see the test result, you can see actually all the tests has successful. They executed, and we have like a 100% coverage of the code. Of course, this is just an illustration of what we are trying to do. The idea is that we will use a similar mechanism to auto-generate the providers and run the test. And the good thing is that because our providers have very fixed interface, right? Basically, there's only like a 3 to 5 method we need to test. And we can pretty much generate the test cases as well, right? Because our provider is mostly state mutation. So if you have a start state and end state, we can use that to generate test cases just to make sure the provider is behaving as expected. So I think this will be a really interesting experiment to see if we can actually use this to auto-generate providers. Actually, one of the things we are trying to do is this bicep provider, right? Because bicep is the case where we have abundant documentations, API definitions, as well as the sample data available to us. So I think there's a good chance for us trying to generate the bicep provider in this way. I mean, even if we couldn't generate like a fully functional provider at the end, at least this will be like a development accelerator, right? So basically, if you are a new developer if you want to write a new stage provider or target provider, you can use this tool to generate the skeleton, right? No, not actually, this is much better than the skeleton code, because if you give you kind of a attempted implementation, then you can start from there, right? Then you can start to iterate and try to finish the provider. So ideally, this will help the community to contribute to the provider library easier, and hopefully we can use this to uh, um, uh, to generate higher quality providers as well. So that's the two topics I wanted to cover today. So basically a quick tutorial of the Symphony repo, as well as the experimental work we are doing. Hopefully this will be exciting to you. And I know that there are a lot of interest in AI at the moment, right? And if you want to contribute to this part, I mean, we will probably keep this code isolated, so that if you want to just focus on making some AI related contribution, we will provide instructions that how you can just contribute to this part of the project without worrying about the rest of the stuff, right? Because a lot of these mechanisms, like what I showed in this diagram here, uh, if we implement this workflow, right, this can be applied to other code generation scenarios, right? I think the key part is this part, right? Sorry. No fear. So this would be the really interesting part, right? So if we have this part working, ideally it can be used in other scenario as well. Okay, so that's all the content I have for today. Going back to you, Harry.
Yeah, absolutely. Well, Hashi, this was great. I think it was a great opportunity for the community to understand just how to get it deployed, but also what possibilities are available with Symphony. So it's great to see that this is a well-rounded session. I do want to open up the floor. We have about 7 minutes left, and we have a few folks that have joined from the community. Is there anything else? Is there anything you guys want to bring up today? But maybe about any of the topics that was discussed, or even anything else.
Yeah, actually, as we wait on that, I also want to mention, right, this community call is for the community, right? What we are looking forward is that if you, as a Symphony user, if you have a topic or if you have something to present, uh, you'll be more than welcome to propose your topic. Then we will schedule into the community meeting. I mean, we are just starting, and hopefully, as we get into more fluent in this meeting cadence, we can give you like a better stage of presenting your stuff.
In addition to that, not just you coming in and present, if you want us to cover something and how you should give a deep dive on, it would be great to get that feedback. So yeah, please do. All right.
Yeah,
Well,
thank you. A lot of new things. Yeah,
uh,
it's nice to see this is evolving. Yeah, thank you. Yeah.
yeah, absolutely. Thank you so much for joining. All right. So if there are no topics from the community, we can go ahead and end the call early. This recording will be made available and will be shared with the email DL. So if you aren't added to that, please make sure that you are on that. I will share the link in the chat once again. But yeah, thank you so much for you all joining. Hope we can see you next week at the office hours.
Thank you, everyone.
Thanks. Ciao.
Bye.
Bye.